Oh, okay. I need to invite Steve. Crap.
I'm not getting any. Oh, okay.
Let's see here. There we go. All right. Who's not here? Steve's not here. Commit. Commit. Oh boy. We're just waiting for Steve, you guys. I try my best.
Good.
Steve, come back. Oh, here he is. Okay. All right. Well, that was weird. But anyway, we're back.
Okay.
All right, Steve. Sorry about that. That was my first time to do that too. So just so you feel better.
Well, that's okay. Okay, I'm going to move on to the next slide here.
All right.
And this, I have to launch the full screen, don't I? Here we go. Okay, if I hit this, then this video should start to play and I can get back to talking. Yes, play. There it is. Okay, so as this plays, you're going to see some things that you saw just a little while ago, but I really wanted to mention El Nino and La Nina here. And I have to wait for the video to, I'm going to try to fast forward this. See, I can't call, oh, there it is. It actually did work that time. So I'm going to jump ahead here a little bit on the video, so it can be done. So El Nino refers to a warming of the surface of the ocean in the central Pacific. And it'll come up here in just a little bit. In the central Pacific off the coast of South America. Now, La Nina is connected with cooler than typical waters, but both affect the jet stream. So here's the area highlighted, which would be the warmer than average temperatures when we're in an El Nino pattern. So Nino, Nina, they both affect the jet stream. It's the narrow, fast-flowing air current that basically acts as a storm track. For us, it can increase the amount of moisture in the air that comes our way during the summertime in particular, but also during the wintertime. So an El Nino, typically, we're going to see warmer weather across the southwest part of the country and right here in West Texas in particular. It's also going to be wetter than average. Now that's a typical El Nino. It doesn't always work out that way. A La Nina, on the other hand, with that cooler air, tends to result in a drier than typical winter and a warmer than typical winter. Again, you can kind of see how that's coupled. Steve. When it's warmer, it's drier. Yes?
Okay, Steve, you need to share the screen.
Oh, I'm sorry. It's
yeah,
just me talking, huh?
Yeah.
Sorry. Thank
okay.
you for breaking
I'm sorry. Sorry, you guys. This is awkward, but we're going to get there.
Go here. Okay.
You got it now?
Okay, so now share. So
beautiful.
Now, can you see it? Okay. So very quickly, what I was talking about is over the lower left corner. I won't go back here because of time, but over the lower left corner of the image out in the Central Pacific is where we would see the warmer than average or cooler than average sea surface temperatures, resulting in either a La Nina, an El Nino, or a neutral pattern. So we are expecting a moderate to possibly strong La Nina this winter. So our outlook for through December anyway is for temperatures to be well above average. And we're looking at this graph, which shows the potential for our temperatures to run above average, which the coloring over the Lubbock area is roughly showing about a 60 to 70% chance. Now, it doesn't tell us anything about how much above average the temperatures might be, but we're also looking at a wetter than, let's see if I try this button. For some reason, it's not advancing. There it goes. So we're also expecting it to be drier than average. Now, this shading here indicates probability of about a 40% chance that our winter is going to be drier than average. Again, it doesn't tell us by how much, but warmer and drier, that's typical. Not all La Niñas are the same. Moving on to some severe weather, I'll talk about tornadoes. This map is showing the maximum tornado rating per county. And so for Lubbock, that's actually F5. That was that 1970 May tornado. Roughly right about there is where we are. You can see it's in the purple, and there are some other purples that are showing up generally out to the northeast of us. So you may have heard of Tornado Alley. We are in what's considered Tornado Alley. Basically, go back to that Gulf moisture, the green that's showing up here on the map. Conditions favor a southeast wind. That'll bring the moisture into the area. This dashed line is called a dry line. If you've watched weather locally, you've definitely heard of the dry line. It'll often set up in the springtime out here over eastern New Mexico. And then during the afternoon, sometimes the evening, it pushes east. So we have the moist, warm air out ahead of that. We have dry, often hot air behind it. And those create instability in the atmosphere, which can touch off the tornado activity. Now, it used to be that we were pretty much bullseye in Tornado Alley. But analysis of tornadic activity more recently puts the center probably closer to the Oklahoma City area. So there's been a slight change in that overall pattern over the last 70 years or so. Clouds, I'm going to probably go through this one pretty quickly, but there are different ways to classify clouds. So we have clouds that are considered to be high clouds and low clouds and middle clouds. So altitude is certainly one of the ways. There's also the type. Puffy clouds, are the clouds towering? Are they developing in sheets? And then there's precipitating and non-precipitating clouds. So this is a chart. And by the way, you can do a search of images, for instance, on Google. Get rid of this little thing on my screen if it'll let me, okay. And just search for a cloud chart and you can find things like this, talking about the different altitudes of the clouds and the different types. Notice at the bottom here, these lower clouds, they have stratus or strato in their name, mid clouds, alto, and the high clouds, cirro or cirrus. I'm going to, there we go. Just going to quickly show you some clouds. Because again, you can look at these online if you want to spend more time, but these are alto cumulus. Cumulus refers to puffy, piled up clouds. Alto, again, those mid-level clouds. Alto stratus, notice this is like a whole layer. This also is in the mid layers, so it's called alto stratus. These are cirrocumulus. Again, they're puffy, they're kind of like popcorn type clouds, cotton balls, if you will. These can be made up of water droplets, sometimes ice crystals. Cirrostratus, the high clouds that often are very thin. If you don't look up, you may not notice that there's actually cloud cover overhead sometime. Here's just cirrus clouds showing up in this particular picture. This little thing that popped up on my screen, and I guess I have to go back here to share. I can get my cursor on it. There we go. Okay, sorry about that. Apparently, depends on where my image will not advance. There it goes. Contrails. This is just some condensation trails from some aircraft. Contrails are actually above the altostratus clouds here because we can see right in here, this is a shadow from these clouds right over there. Cumulus clouds, we see these often on fair days. They're just little puffy clouds. They don't have much vertical development. This is a cumulonimbus cloud. So cumulus, it's piled up. Nimbus, rain. That refers to rain. So this is actually a thunderstorm that we're looking at from a distance. Stratocumulus, we sometimes see these at sunset, really beautiful. So it's piled up clouds, kind of puffy, cumulus, but also kind of in a sheet. So it's a hybrid stratocumulus. And once again, I don't know what changes here that it doesn't want to, okay. Nimbostratus, so a layer of clouds producing some rain, also a rainbow in that particular one. And these are stratus clouds. It looks like it may be producing some fog, possibly some rain. Mammatus, so at the top of the picture, we sometimes see these here, typically on the underside of a thunderstorm anvil. Now these do, let's see. The problem is, let's see if I can get my cursor doesn't want to move the way that I expect it to. What are you guys seeing on your screens right now?
I'm seeing a red cursor in towards the center right.
Yeah, okay. So there we go, I think I'm back. So these are not severe weather in themselves, but they'll sometimes accompany a severe thunderstorm. At the bottom of the picture, notice those rays. Those are called crepuscular rays. We get to see those actually pretty often around here too. And so apparently when something else pops up on my screen, I lose control of it briefly. Lenticular clouds, they sometimes look like spaceships. They're often formed near mountains. And these are a special cloud. And yes, we even see these around here occasionally, but they're pretty rare. Kelvin-Helmholtz clouds. See the waves showing up right there? We have the atmosphere moving in different directions and often at different speeds. These are just like waves on the surface of the water, but it's happening in the atmosphere. The atmosphere basically is a fluid. It moves just like water does. And again, I have these little things that are popping up on my screen, taking away control. So a lot of people think of Texas as just big and hot, but we have a lot of different climate regions. So again, you can find this map by searching the climate regions of Texas, natural regions of Texas, but we're in the high plains, the orange color. Out to the far east, you'll see the piney woods, the oak woods, the area that gets much more moisture than we do here locally. Just want to talk about climate. The ice sheet maximum about 15,000 years ago, it's extended down into the Ohio Valley. This is a glacial sheet. Yes.
Can you hang on 1 second? There's two people trying to get in.
Okay.
Hold on.
Mm-hmm.
Okay, everybody should be in now.
Okay.
Sorry about that.
So,
I'll give you back your.
okay. So this particular graph is showing
Shit. Admit.
Hey, Kippy,
Yes.
you're unmuted and Steve is muted.
Okay.
okay.
There we go.
Am I unmuted now?
Yes.
Okay.
Sorry
Sorry
about
about that. I apologize, you guys. I'm not very Zoom friendly either.
Either am I. So the graph previously
Doing
was a
great.
500 million year graph of temperatures. They have to use
Wow.
things like tree rings and other things to come up with that. This is from an ice core from Greenland, and this is the main source of trying to deduce what temperatures have been like. This is the last 10,000 years or so. So if we go back to 1970, we've been warming. If we go back to 1930 or so, we've been cooling. Go back to 1850, we've been warming. But you can see we have some cooling periods, go back to the little ice age, not a good time for humans because of the cold, not a good time so much for plants and animals either. Further back, you can see medieval warming, then there was another small big dip, Roman warming further back. So the point here is that it changes, and depending when you're going to start your timeline, you will see warming or cooling. But basically, since about 1850, the overall trend is that we are a little bit warmer overall. So hurricanes, we hear a lot about hurricanes and how bad the hurricanes are. So this chart is showing that in major hurricanes, categories 3 through 5, 3, 4, and 5, that there's been no change, really significant change in the frequency or the intensity of these hurricanes striking the United States. Overall, this goes back to 1900, so that's pretty much the hurricane record. Our tornado record is about from 1950, which this graphic is showing strong to violent tornadoes. So hurricanes are on a category 1 through 5 scale. Tornadoes are on a category of F1 through F5, or EF1, EF5. The F stands for Fujita, E stands for enhanced. So we now have the enhanced Fujita scale. This is actually showing a decrease in strong to violent tornadoes across the United States since 1950. So we have better detection. Everybody has a camera, a video recorder in their pocket these days. We have a much better network of radars to detect severe weather, including things like tornadoes. And we have people who are storm chasers that go out and are trying to intercept these storms. So that is basically, see if I can get stop share to work for me. Getting all sorts of other little icons popping up. Kipra, I don't know if you can do stop sharing, but okay, thank you. But that was kind of quick. I wanted to try to leave a little bit of time for questions that you might have about weather, about the topic. So this is my first encounter with your group too. Kipper, I'm not hearing you.
Okay, I'm unmuting everyone.
Okay. Questions?
I had a question. I don't think you talked about it, but what causes things like the dust storms and the haboobs around here?
Oftentimes it's associated with the outflow from a strong thunderstorm. So a thunderstorm has a strong updraft, the air rising, that's what forms the towering clouds, and eventually that tower hits the troposphere and stratosphere and starts to spread out. There's also a downdraft, and that's where we'll find the rain. The interface between the updraft and downdraft is typically where we'll find the tornadoes. But especially when a thunderstorm is dying, the air that's been lifted aloft is cooling, and as it gets cold, the updraft dies, thunderstorm is dying down, and all that cold air rushes to the ground, and it may hit the ground at speeds greater than 130 miles per hour. So if you were to just take a bunch of water and pour it out on a flat tabletop, it kind of spreads out in all directions. Well, that's what's happening with the air. Again, the air acts just like a fluid. So that 130 miles per hour hits the ground, and the speed may still be in excess of 100 miles an hour as it spreads out. Now it's going to weaken some the farther away it gets, but that's where most of our haboobs, dust storms, sandstorms come from. And sometimes they accompany cold fronts that are moving into the area too.
When did we start using the word haboob, Steve? Was it when we entered the Middle East with our armies?
It's been around for quite some time. I've actually looked at some of the earlier usages of it, and I don't remember when that is. It's it really more of a sandstorm kind of thing because it is from the Middle East, but it has some particular characteristics. That well-defined wall of dust or sand moving across the landscape that you'll often see. So a lot of times our actual dust storms, they don't really begin with that well-defined wall.
So there are
That would be right. That would not technically be a haboob, but we do see occasionally those well-defined walls moving across the area. And they're more typical after drought conditions have been in the area and we start to see some thunderstorms.
I have a question about the Sahara sand and the smoke residue that we're getting from the west.
Mhm.
Is there a way that weather forecasters could make that part of their forecast? I find that just plain allergies are bad enough, but my eyes really react when we get the sand and the smoke dust. Is there any way to find out what's happening and have a warning other than going on air quality sites?
The air quality site is probably the most consistent. The Texas Commission for Environmental Quality, is that what it is? TCEQ, I
Yes.
think.
Yes.
And I actually look at that one to see what's going on. Their main concern seems to be ozone. It's more of a factor in our bigger cities here, not just in Texas, but anywhere. This year, we have tried to do a little bit more about the dust and the smoke forecasting. So
Yes.
we've on occasion shown those graphics. Some people are much more sensitive, and some people will have no itchy eyes, no allergy symptoms, and others will. When it comes to allergies here, the problem that I have is that as far as I've been able to tell, there's no one that is actually doing an allergy count. What they do is they put collectors around town, or one on a roof, and they actually collect particles, and then they take it into a microscope and they count the different types of pollen that they see, and they record that. And that's really where an accurate pollen count comes. And since I've been here, I've never found anybody who does that. And yes, you will see pollen forecasts, pollen counts on the air here, but it's a generalization that's coming from a couple of people that do websites, not people, but organizations that do websites that kind of just generalize things. Well, if it's like this in Albuquerque and it's like that in Dallas, then it's probably like this in Lubbock. And that's why I personally have stayed away from the pollen and allergy counts up to this time.
Thank you.
I have a question. I work at Holland Gardens, and last weekend on Saturday, the air was really, really calm. And then all of a sudden, this gust came through. It went through the nursery. It lifted up probably at least a 200 or 300 pound netted tarp, 30 feet in the air. It threw stuff all around, but only in one little section. And I never saw any dirt. And then all of a sudden, it was real calm again. I've never seen anything like it. I'm just wondering if there's any kind of a term or phenomena for this, or.
I'm not sure in this particular case. It sounds kind of like a dust devil, and dust would imply that you would see some dust at least with it, but that's not always the case depending on what surface it was passing over. What they are pretty typical really on kind of calm days, little breezy days, but with a lot of sunshine. Sometimes we'll even have a few of the puffy cumulus clouds in the area. So it kind of sounds like maybe it was a dust devil that went through the area. Not sure.
It was bizarre. It really was. I mean,
It keeps the weather interesting.
it did, literally.
You do have an interesting job.
Yeah, I do.
Anybody else have questions?
Speaking of interesting, what's the most interesting change you've seen in our local weather over the time you've been here? You've been here for a while watching it. Is there anything noteworthy that's different from when you started?
Our nights are noticeably, well, maybe not so much noticeably, but our nights are warmer. And that's really where most of the warming that you hear about, that's about at least a third of that warming is coming from our warmer nighttime temperatures. And it appears to be due to an increase in relative humidity. I'm talking about generally the US, more of the globe, northern hemisphere in general, but we have seen that increase in our nighttime temperatures. There's, again, for the US as a whole, the daytime temperatures actually seem to have held steady or come down a little bit. But when you hear them talk about what the temperature is, it's a reference to an average temperature, and not, of course, at one spot, but over the globe. Average temperature being what is the low for the day, the high for the day. It's really a mean temperature. So that, and also just the cyclical nature of the weather. We have seen, like this year in particular, less severe weather, but that kind of goes along with a drought developing, which is what we were looking at during the springtime, drought conditions kind of developing. So it seems as though we have perhaps a little less tornadic activity than when I first came here. And I mentioned, it seems like, I don't know if the audio was working right then, but the Tornado Alley, which we were pretty much in the bullseye of back in around 1970, seems to have shifted a little bit more, say out towards the Oklahoma City area.
Thank you.
What is a downdraft? I hear about it with airplanes, but what is it? Could it be something that Sue described?
So a downburst maybe
Downburst,
is
sorry.
downburst, right?
Mhm.
So when I was talking about the thunderstorms and have the updraft and the downdraft, and when it dies out, that cold air just plummets to the ground. That's a downburst.
Okay.
So that is that downward motion of the air, and it comes out as a burst. If you are, sometimes they're not. If you're in an airplane and you happen to be flying near a thunderstorm or under a thunderstorm and there's a downburst, that can literally slam the aircraft down to the ground or cause it to drop 10,000 feet in just a matter of minutes.
Yeah.
Of course, neither one of those things would be good. They now have sensors actually located at least major airports. I'm not sure how far out those sensors go, but they're try to detect conditions that are favorable for that. So airplanes actually encounter downburst conditions less often. When they first started noticing them in the early days of aviation, when it was getting to be a pretty major enterprise, they didn't know about downbursts at that time, and aircrafts were a little more susceptible to that danger.
Any more questions? Well, Steve, we sure appreciate your time, and especially since you've been recovering, I guess, or you've been in
I have been.
quarantine.
Yes, this morning is actually my first morning out of my, pretty much out of my space that I've been limited to.
Oh, good. Congratulations.
Thank you.
I want to thank everybody, and I apologize for any of the technical difficulties. We'll get this worked out by the end anyway. But thank you, Steve, a lot, and thanks everybody for showing up.
And thank you all.
Next time.
Appreciate it. Bye-bye.
Bye-bye.
Yep. Bye.